pleasure and privilege to be here to introduce Steve tonight. We met many years ago at a BioBlitz up at Westernbert, where we were introducing families and kids to the wonders of bugs in the undergrowth, and it was a great afternoon. And anyway, over a cup of coffee, we were talking, and I suddenly realized who I was talking to. This was Steve Nicholls, the filmmaker who had made Alien Empire, that TV series that had blown me away when I was so much younger. And anyway, and we've been in contact over films ever since. So as you've seen from the exhibition downstairs, that's all about persuading people that invertebrates are beautiful and useful. And Steve has been doing this with film for so many decades. He has made so many films. He has worked with so many people. He was a boy up north. He grew up in the Yorkshire, in Yorkshire on the River Tee, and he was fascinated by the plants and animals that he would encounter along the banks of the Tee and in all the surrounding environments. And this fascination with nature led him on to do a BSc at Bristol, and he then did a PhD, and he did some postdoctoral studies as well. And one of the themes that ran through this was his great love of dragonflies, which still is with him. He is Mr. Dragonfly. But the BBC Natural History Unit was just next door, and he couldn't resist. When a job came up, he transferred, he left academia, and he became a filmmaker and producer, and he's been doing that ever since. He's made films about so many things. He's made films on, sorry, I have a list here somewhere. From bisons to crabs, eagles to reindeers, ants to, of course, dragonflies. So he has been prolific. And his latest films, Insect Planet, which I was invited to the premiere of 2 years ago now, I think it was. A bit more, was it 3 years ago? Oh, crumbs. Time flies when you get to my age. Anyway, that's available on the Curiosity channel. If you have a chance to watch it, it is brilliant. And it is, and of course, it's not narrated by Attenborough, but someone much better. The captain of a starship. And sorry, Steve, I can't remember her name. Kate Mulgrew, yes. Captain Janeway, she narrates it, and it's fantastic. The film opens, space is not the final frontier. It's wonderful. So if you get a chance to watch that. But anyway, so Steve has been carrying the torch for invertebrates for many decades and producing many wonderful films. So tonight he's going to tell us a bit more about them. So please give a very warm welcome to Steve Nicholls.
For the first time in my life, I'm in awe of me now. I should also say that the last Dragonfly film we made, which was all made around Bristol and Wiltshire, actually, even though that did have David Attenborough narrating it, is still available too on Sky Nature as well, if you really want to watch that. And as Peter said, Planet Insect, which we'll be talking about tonight, of course, is available on Curiosity Stream, which you can get as part of Amazon Prime, I think, for those of you who are into that kind of thing. Anyway, thank you all for turning out on a really nasty, wet night. I know the main draw was the exhibition downstairs, and I shall try to at least partially live up to that up here, but I do appreciate the fact that it's not at all a pleasant night. And welcome also to the folks, more sensible folks, who are sitting at home watching this on Zoom in the warm and dry. So yes, I'm going to talk about some of the challenges of capturing insects on film. As Peter said, I've been making films now for, and that's over 40 years. And believe me, some mornings it certainly feels like it. But in that time, we've come across an awful lot of challenges that we've had to solve. And as Peter said also, since I was an entomologist at Bristol, I've always tried to focus on, making the best of, well, invertebrates in general, but insects in the main. That comes with a whole set of challenges. Tonight, where's the little sticker gone? Here we are. I'm going to talk, I'll show you some examples of how we filmed and what we filmed from the two series that Peter, you think it was planned, wouldn't you, that Peter mentioned. From Alien Empire, which was transmitted on BBC One in the mid-90s, actually. Gosh, we were all very young then. And obviously, technology was advancing then, but not as advanced as it is now. So this was all shot on 16mm film with all the problems that had. And I'll show you some examples too from Planet Insect, from Curiosity Stream, which was, it must be a couple of years ago, 2 or 3 years ago we finished it. We started it during COVID, so because that made life even more difficult. There are quite a lot of challenges associated with making films on insects. The first one, curiously enough, is actually persuading people to part with money to pay you to make films on insects. It's remarkably, I say easy, nothing's easy in terms of raising money for science and nature documentaries these days. The whole broadcast market has changed completely. And particularly natural history it's got very difficult, and it's kind of not quite collapsing as a broadcast market, but so much is changing that it's very hard anyway. But even today, and certainly in the past, it's always been relatively much easier to get money to make films on the big charismatic things, lions eating zebras, whatever it might be. And the little stuff is much harder to persuade people that it's worth doing. And I've always seen my mission, as Peter's already alluded to, if mission isn't too stressing the word, as creating science outreach for people. To try and make sure that people have a balanced view of the natural world. And it's very hard to have a balanced view of the natural world if all you think about is, lions eating zebras or whatever. Most of what goes on in the world is actually really to do with the little things. The great sociobiologist Ed Wilson once said, these are the little things that run the world. But you try convincing a broadcaster with money of that, and it's a lot harder. So actually, before Planet Insect, I was lucky enough to be asked to be a series producer and make this series for Apple TV. And we got very excited about this, largely because they gave us a stupid amount of money. In terms of Apple, it was like probably the money they found behind their sofa. But for us, depauperate filmmakers, it was an absolute fortune. And they said, we wanted to do a series, 12-part series, on the small worlds, tiny world, hence the name of it. And we could even afford to pay Paul Rudd an enormous fee as Ant-Man to narrate it. But even there, it showed the kind of inherent bias. So here we are, setting out to make 12 parts on what the small world looks like out there, perfect. And then most of our conversations with Apple were them saying, yeah, but don't put too many insects in it. We don't really want all those insects. One show on the Namib desert, we had fantastic sequences of different kinds of ants and of termites, and they said, oh, you can't have ants and termites in the same film, they're the same thing. No, one's holometabolous and one's hemimetabolous. How can you say they're the same thing? That didn't really work. But in the end, we were very happy with what we ended up with for this series. But it was a shame, and I was reminded in those conversations of something that Robert May, Baron May of Oxford said, who's a total polymath, a biologist, a statistician, a mathematician, amongst many, many other things. Sadly died in 2020, I think. But when he speaks about biological statistics, I kind of believe it, really. And he said at one stage, there's just over 1 million species of animals have been described, and by far the largest majority of those are insects. So, to a very good approximation, all species are insects. And I think that's, that's pretty good. I tried it on Apple, and, they weren't having any of it. So, but nevertheless, as I say, and this is still available on Apple TV as well, and it's aimed at a younger audience, and it did work, despite the fact that they were after more cute animals, and as I pointed out to them early on, all the things like hairy and cute in that world are rodents, and they all look the same. So, but anyway, we still made a half-decent film of it. But let me not bang on too much about the kind of politics of making insect films, although I'm sure I could fill the whole evening with that, and tales of woe. But I wanted to talk tonight really about the practical challenges of filming insects. So it will not have escaped your notice, I'm sure, that insects are generally quite small. They range from small to very, very, very small. In this case, incredibly small. This is a parasitic wasp, or a parasitoid wasp. I think this is Trichogramma. It's probably Trichogramma or even essens, but don't hold me to that. I'm not betting my next pint of beer on that. But to get a sense of scale, those little barrel-shaped things there, they are the eggs of clothes moths. Now, clothes moths themselves are pretty small. Their eggs, if you do see them, and you won't see them unless you breed clothes moths, as I did, in a container with a black bottom, and it looks just like white fleck. I mean, it's like smaller than dandruff, so it's really impossible to see. And yet, it's big enough for these wasps not only to stand comfortably on them, but they actually lay their eggs inside those eggs, and their larvae feed on the nutrients inside those eggs until they emerge as adult wasps. And they're really, really good at finding these eggs. So much so that these are being bred now as a possible biological control agent. And certainly when better than poisons, and certainly when we finished filming with these, we had quite a big supply. I let them all go in our wardrobes at home, and well, we haven't seen so many clothes moths since, so hopefully they're still doing their job. Being small presents some challenges to film, but also being small, well, it has some real advantages, both to insects and to us filmmakers as well. One advantage is that being so small, you can get a lot of individuals in the same place. You can get fantastic images like this. And being so numerous at times, actually, well, it does several things. It helps buffer them from population crashes and declines. And insects, throughout their history, have been quite resilient when it comes to extinction. But it also means that these things are so numerous that they, as indeed insects do in many other places, underpin their ecosystem. These are brine flies of the family Phaedridae, and these particular ones are living on the shores of Mono Lake in California, where they form a black ring right around the lake. And if you walk through them, it rises up to about knee height, like this kind of black miasma floating over the surface. It's really weird. But and there's not much else in the lake. It's basically brine flies, brine shrimps, and cyanobacteria. So it's a nice, simple ecosystem. Although every year, particularly in the autumn, the lake gets inundated with huge numbers of grebes and of phalaropes as well, little waders called Wilson's phalaropes. And during the nesting season, California gulls come here to nest, and they nest on islands, predator-free islands in the lake, and feed on the brine flies, or they try to feed on the brine flies, and they do that by racing through a swarm, so it all flies up, and then just holding their beak agape and just snapping randomly. And I guess they must catch some that way, but it seems very, very hit and miss. But actually, I mean, you get this kind of spectacle elsewhere. in North America around Great Salt Lake in Utah it is, but also in Hawaii there's a little tiny island right at the far end of the Hawaiian chain before it dips underwater to become the Emperor Seamount chain called Laysan. And there's a lagoon in the middle of that which is just solid with brine flies. And there it's not gulls that feed on them, but an endemic duck used to be called the Laysan teal. I think it's just called the Laysan duck now. And it does the same thing. It runs through these swarms of flies and snaps its bill to try and catch them. But of course, being a duck, it's much, much more humorous than watching a gull do it. I mean, I know you're not supposed to laugh at these things or anthropomorphize, but it is hilarious watching Laysan ducks trying to feed on these things. So that's an advantage. You've got big swarms, and you've got lots of individuals in a place. The other thing about insects being small is you can cram a lot of species into one area. They can fill a lot of different kinds of niches, which means they can become very, very diverse. So let me just show you some diversity. I mean, there's about 1 million described species, and I'm not going to go through them all tonight. But here's some of my favorites. This is a bush cricket, or katydid, from Colombia. Even the scientists weren't quite sure which one this is. It's a nymphal stage as well, which doesn't help. But it's a real beaut. Here's a caterpillar called Philotherma rosa, which, these are rare at home some years. They're fantastic as caterpillars. It's a moth in the family Lasiacampidae, which is the same family as eggers and lappet moths and things in this country, but this is an African species. And the adult's pretty, not very exciting. Well, it's fairly exciting, but the caterpillars are just fantastic. I mean, they're just outrageous things. And those hairs are very irritating as well. So if you rear lots and you keep having to change the food, you either wear gloves, which I never remember to do, or you get very swollen rash on your hands. The adult stages of these things are varied as well. So butterflies, obviously, and moths, a huge variety of shapes, fill a huge variety of niches, lots and lots of amazing colours, or sometimes no colour at all. In this case, this is a glasswing butterfly from Costa Rica. Absolutely gorgeous little thing. It's a little angel in the rainforest, really. And this is one of my favourites. This is a tree hopper. And I haven't made this up. It's not AI. In fact, I did see someone try and make some AI tree hoppers, and they're nothing on the real thing, which is great to know, isn't it? That natural selection beats AI hands down. It's a species. I think it's called Dacidium, but a lot of people just refer to it as the helicopter tree bug. It's a South American species again, and it's got that, which the scientists say, it's to disguise its outline and make it look that isn't like an insect. And I think, fair enough, it doesn't look like an insect. But there's lots of species of these things, the family Membrastidae, and they, some of them have very elaborate, carry a structure like that on their back, but it's very elaborate and it's shaped like an ant. So obviously they're kind of, trying to persuade predators that they're an ant and not to be tangled with. Some of them just have like very sharp thorns on their back, that group that's really just called thorn bugs for that reason. And they're often very communal, and so they'll all line up on the branch of a plant, and it just looks like a thorny plant. There's just thorns all the way up it, but if you really breathe on it sometimes or something like that, all the thorns get up and walk away, so it's not a plant. My old professor at Bristol, Howard Hinton, was heavily into these things, and he used to spend every summer vacation off collecting, usually in Mexico and Central America, where he'd head off armed with a butterfly net, specimen tubes and a revolver, because he would go into what he described as bandit country, which is the essential collecting equipment, and then come back with a load of stuff. And if you showed even the slightest bit of interest in insects, then you'd be hauled into his office when he got back and shown these amazing collections of membracid bugs, which were just the sort of things he loved, because he was always asking questions about, what's that doing? How does that work? And these things are, beg those kind of questions completely. Anyway, this is not meant to be a talk on insects per se, but I think this slide summarizes it from a display in the Oxford Natural History Museum, which just says simply insects are incredibly diverse. I often end up saying in commentaries or in books, the most successful group of animals ever to exist. And I know that you could argue that there are rivals for at least a number of species amongst the nematodes and amongst the mites, but let's face it, nematodes are all, apart from a few parasites, really, really small, and so are mites. And mites are quite diverse looking. They're not uninteresting things at all, but nematodes all look the same. So I'm pretty happy telling people that insects, in this sense, are the most successful group of animals. And so, of course, that's fantastic for a filmmaker because you never run out of stories. And 40 years later, there are still lots and lots of things that I'd like to film in the world of insects. Let me just show you a film. So this comes from Alien Empire, and this just goes back to that first picture I showed of those trichogramma wasps. Because even though some insects are really, really, really small, they're all worth looking at, and they all have often very extraordinary behavior. So this sequence was from Alien Empire about two kinds of parasitoids that attack cloverworm caterpillars.
Insects are never free from danger, and often an insect's worst enemy is another insect. A cloverworm caterpillar seems helpless, defenseless, to a hungry ladybird larva. But the caterpillar can escape. It drops out of sight on a line of fine silk. Its victim seems to have vanished, so the ladybird larva just gives up. Once the threat is gone, the caterpillar hauls itself up and carries on eating. This wasp is also hunting the caterpillar, not to eat it, but to lay her eggs inside it. And a wasp isn't so easily fooled. The caterpillar tries its vanishing act again, but the wasp just abseils down the line. Injecting her eggs won't kill the caterpillar straight away, but it will die as her grubs hatch and eat it from the inside. But its day isn't over yet. Another kind of wasp needs a caterpillar incubator. This one reels in the lifeline and injects her eggs. When they hatch, they'll eat the first wasp's grubs. Even the muggers get mugged.
Great. So yeah, I think it's fair enough. Even the tiniest of insects have got the most extraordinary lives to lead. So just being small is a challenge, but we have the lenses and various techniques that can get us over that. But there are other challenges. One, which we share with a lot of other wildlife filmmakers, is just the sheer physical effort, as it were, to try and film insects. Just the sort of practicalities of working in dangerous places. So for the same series, we wanted to film these giant honeybees from the Himalayas, which build these enormous combs, 3 feet more long, dangling off the underside of ledges on cliffs in the mountains. Often, many dozens together. They're different colonies, but they all build in the same sort of place. And so that's just a pure physical problem. You basically have to get dressed up in a bee suit with a good old film camera, as it was in those days, and the bags with spare magazines of film, because each film roll only lasts 10 minutes, which was always a real pain. And then be slung on ropes, and then be basically dropped over the side of a 500-foot cliff to film these amazing nets. I mean, well worth it. They're fantastic. I should say that the local Nepalese people, they harvest the honey from these things, but they do it by making rope ladders, the most flimsy-looking things you can possibly imagine, and no safety harnesses, whereas at least we had state-of-the-art, or state-of-the-art in the mid-90s sort of climbing kit. And they climb down these, and a whole bunch of other villagers go to the bottom of the cliff, where they light fires to smoke the bees, just the same as beekeepers will do here. And then the guys on the rope ladders have a big long stick, and they poke bits of the comb off, which the bees don't like particularly, so they must get stung terribly. And the comb falls down into baskets waiting at the bottom, and they can go and enjoy the honey, which is amazing, absolutely delicious. But so that's a kind of physical problem, but there are lots of other problems which I always think more challenging and more fun to solve. And one is that the macro world, the tiny world, yes, we've got the lenses like I showed you on that parasitic wasp sequence to magnify them, but those are very two-dimensional images. They can be very claustrophobic, and if you make a whole film about small insects, which I'm quite happy to do, then it can get very, very claustrophobic. You kind of, you don't really feel you're in that world. You feel like you're peering at it down a microscope. So one of the things we've always tried to do, and technology for this has got better and better as time's gone on, is to move the camera in a really controlled way. And what that does is basically make the image seem much more three-dimensional, and you feel more like you're in the insect's world than sort of peering at it down a microscope. So that, however, takes an inordinate amount of equipment in the field. So all our producers are strength tested before we employ them. This is Kim Bartholomew as the other producer on the Planet Insect series. And yeah, no excuse. Being a woman is no excuse in this business. You still get to carry all the kit. And in this case, this was a kit that we were taking out to do this. Now, so I decided what would be great would be to get a shot where the camera actually rotates around a feeding hummingbird hawk moth. I thought, that would look really good, and it would show the hummingbird hawk moth off to its, glorious best. But it has to therefore rotate around a single point. So cameraman Kevin Flay, who actually was the main cameraman on Alien Empire and the main cameraman on Planet Insect, which shows that we've been working together about 35 years now and still haven't fallen out. But he came up with this device to do it. So we called it the Kevmatron. So the Kevmatron basically it's got a central pivot and two rails running through it, which the one half can carry the camera and the tripod, and the other half is counterweighted to match the camera. And then purely manually, you can spin the camera, and if what you've filming is somehow remains in the center of that the hole there, then the camera will rotate beautifully around it, and it will all stay in focus, and all will be magic. So we chose hummingbird hawk moths because when they start feeding, hovering in front of flowers, I'm sure some of you have seen them, they stay for maybe a minute, maybe 2 minutes, just moving around. So they're kind of stable like that, and we thought that might work. So we can't just rely on catching these things because they're migrants and they come in varying amounts of numbers across the summer. So I reared a whole bunch from caterpillars, and then as they hatch, we knew we had perfect hawk moths in whatever numbers we needed. So that was step one. Step two was to find a nice meadow and then partially trash it. But the part of that was building this big cage around it, because didn't want the hawk moths disappearing off into the distance after I'd gone to all the trouble of feeding them for 6 months. So So that was that. And then we could, and they're good and hungry when they've just emerged, because they're literally new, they haven't started feeding, so we thought that will give us our best chance. And so we introduced them into this little flight cage, just to sort of let them find the flowers. And once they started feeding, we could whip that off and then spin the camera around it, just manually, just can push it around, because it's only filming at, you know, maybe 3 times slower than normal, so it's not horrendous. The results are, you know, worked out quite well. We were quite pleased with it, to be honest. It just makes a difference, but you can see what I mean. They're much more three-dimensional shots than the sort of straight, you know, 2D shots. A lot harder to do, but, you know, worth the effort in the long run, I hope. I hope you agree. And also fantastic insects as well. You've got to love them. So that was that. Now, we also, I mean, go somewhere like this in South Africa, in the flowering season, or when the winter annuals flower, and you can imagine with that amount of flowers around, there's some great insect stories. But of course, as usual, as you'll probably realise from what I've just shown you, filming insects isn't just about lying in a field of glorious flowers waiting for things to happen. Yeah, okay, well, sometimes it is. So sometimes, you know, you can film stuff as it happens. This is Kevin basically trying to film long-legged bees, red reviver species, feeding on a particular flower called a twin flower. And the only way to do that really is just sit and wait with a twin flower until it happens. So he got to spend some very pleasant days in the Makwaland, lying in glorious fields of flowers. But actually, one of the main reasons for going down there was to film this little guy, which is it's a dung beetle, but it's given up on dung. Can't blame it really, to feed its larvae. Instead, it actually buries segments of giant millipedes, which is great, a lovely story, but actually it can't actually kill millipedes. So how it solves that problem, I'll show you shortly in the final sequence. But again, we're faced with the problem of wanting to sort of move the camera to tell this story. So this time we wanted the camera on rails so we could track it backwards and forwards very smoothly. And as you'll see there, we're using a probe lens, which are fantastic lenses for getting you close but keeping a kind of vista behind it. But obviously that's a quite high structure, so there's only 2 ways around it. One is dig a very long trench for Kev to lie in, and that method has been employed in different places. A slightly quicker and less destructive method on this wonderful landscape is to just have a little table and build a part of the landscape neatly raised up, and it works a treat. I'll let Kevin explain exactly what he's trying to do, because I was hoping he was going to be here tonight, but unfortunately he's been able to go and do something else.
Yeah, what we've got here is a roller dolly which sits on a couple of sets of rails, which means I can move the camera up and down. The set is actually built on this table in front of me, and that just means that I'm able to focus here, trek past it, but then have all the background behind moving in parallax.
But using technology in the field comes with its own problems.
Setting up the slider dolly is quite a challenge in sand, because the sand shifts all the time, and of course as soon as the wind blows, sand goes everywhere. We've been getting sand under the wheels, all around all the mechanism on the tripod head, and of course worst of all on the camera. I can actually write my name in some of the sand on here at the moment, and I spend my entire day with a paintbrush just trying to keep sand off the body as much as possible.
There you go, you see, cameramen, nothing but complain the whole time. I take them to these places. And yeah, that in the end worked really well. So how does a dung beetle that is no longer a dung beetle get a piece of millipede from a millipede it can't actually kill? That was the whole story we wanted to film, and this hopefully will explain it.
Some dung beetles have abandoned dung altogether. This species feeds its young on millipede flesh, which is a problem, because it can't kill a millipede by itself. It needs to hire an assassin. Millipede assassin bugs. Assassin bugs even work together to overpower a really big millipede. They stab it with their sharp mouth parts. Then they inject it with fast-acting lethal toxins. Once they've finished, there's still plenty left for the beetle family. It uses its wedge-shaped head and powerful legs to separate the millipede into convenient chunks. Small enough to bury, but big enough to feed its larvae. And maybe a little bit more appetizing than dung.
There you go. Extraordinary beast. This is great, and this is all stuff that we've done in the field. But there's a lot of times when you just can't even do that. It's too fiddly, too complicated. It's going to take too long, whatever else. So we move into the studio. We're lucky. You'll see more of this studio over the remaining part of this talk. But there's a studio out at Fayland called Farm Studio for the good reason that it's on a farm. And it's essentially a very large barn, but it's full of the most outrageously complicated equipment. And the guy who runs this, Nick Pitt, has been doing this for as many decades, I think, as I've been making films. And we worked together over that time and built up a fantastic resource of ways of getting insects to do things in ways that work for the camera as well as for the insect. Because once you bring things into the studio like this, it's not an easy option by any stretch of the imagination. You've got to get the conditions for whichever insects you're filming exactly right, or they won't behave at all. You've got to maintain the insects when they're not on the studio set. So we've got an insect green room where we can make sure that our stars are well looked after, heated and humidity controlled and everything. And then there's also the problems of the cameras. I mentioned these probe lenses that the camera's got on there as well, which works to break the claustrophobia that I described earlier, because you can get very close to an insect and therefore see a lot of it, but you can still see a lot of the background too. But in a studio setting, of course, that's a bit of a problem because you don't really want to see a studio wall behind. So in some cases, we use this technique. So we get these enormous 4 meter by 3 meter prints. They're called translights. Basically, it's a photograph that we've taken in the field where we want to set the story, or in the right habitat or whatever. And it's printed onto a reflective material that bounces light back off it quite effectively. So you get the same kind of lighting effect as you do off the lit foreground. And the two blend together pretty well, so they're pretty seamless, and you have a lot more control over things in the studio. A couple more examples of that from the studio. Rainforest canopies are not the easiest place to work, and if you want to film things in high speed, you need a lot of light, which you don't often always get in bits of rainforests. So this is a little bit of rainforest recreated in Fayland to film butterflies flying in high speed to show their wing flight characteristics. And again with a different translight at the back. Anyone really observant will spot that I shot the background in Borneo and the foreground is meant to be in Queensland, but close. Also, when it comes to rain in rainforests, you don't want to be out in the rain in a rainforest, or at least Kevin doesn't particularly with his camera. So again, when we wanted to do a rain in the rainforest sequence for Planet Insect in this case, again, that's best done in the studio with our patented rain machines. And again, you can have all the equipment that you want. So the sequence this was for, I wanted to do a sequence which showed as one of the many extraordinary things about insect exoskeletons, cuticle, is that it's waterproof, as it's waterproof both ways. It's one of the reasons why arthropods were so good at conquering land well before our ancestors crawled into the mud on dry land, because they're supported apart from anything else, but they're also protected against desiccation. But it works the other way as well. There's a waxy layer on the outside of many of these cuticles which is completely hydrophobic, and water literally just bounces off it. Not only off shiny beetles, but off butterfly wings as well. The scales on the butterfly wings are hydrophobic as well. So that was what we set out to illustrate. And so to make it work, we have to film something in the field. So we did film storms in rainforest in Queensland, which was tricky, but we weren't trying to film bugs doing things at the same time, nor were we trying to use high-speed cameras, which, as I said, need a lot of light. So I'll show you the sequence, and then I'll explain how some of the other shots happened that we did, because they all involved different bits of crazy kit.
The exoskeleton is so water repellent that raindrops just bounce off. Scales covering a butterfly's wing are made of the same stuff as the rest of the exoskeleton and are just as unwettable. Droplets simply roll away, keeping these aerofoils in perfect shape. We know the very first insects to evolve already had an exoskeleton.
Well, you'll have to watch the rest of the film to find out what happens next. So you can see there's got quite a variety of shots in there. I mean, for starters, the biology is fantastic. I mean, I filmed lotus leaves before, which are the things that have kind of bio-inspired scientists to make self-cleaning paint and stuff. But actually, particularly butterfly wings are just as good. They behave just like lotus leaves, but it's a different sort of mechanism that's making them that waterproof. So you saw in there a shot rotating around the morpho butterfly as it took off. So you see, once I had an idea, I keep having it over and over again. So it was like, well, it worked so well for the hummingbird hawk moths, so let's try it with a morpho butterfly, but let's do it with a high-speed camera. Now, the problem with that is you're slowing everything down maybe 40 times. So if you slowed a sort of ordinary movement around 40 times, you wouldn't see the camera moving. Or if you wanted to see it do a full 360, you'd probably have to wait for 20 minutes or something. So good slow television, I suppose, but maybe not in one of these films. So we had to develop a different system. So this is the same principle as the Kevmatron, but it's actually powered by an old rugged, very powerful motor belts which drive it around mechanically at a much, much higher speed. So we christened this one the Wasmatron. And I think, I don't know if it's ever been used again, actually, after the shots we did with it, but it was good fun. There's some footage of it kind of working. So you can get it moving by spinning it, and then the motor kicks in, and it just goes faster and faster and faster. And honestly, it's really quite scary. Well, it's even scarier for Kevin with his camera mounted on it, because if it had come off, it would probably have gone 30 yards into a brick wall. I mean, there's lots of problems associated with it, because you're seeing all the way around, so you have to build some kind of set that you can cover all the way around. But actually, we found that great big sheets of cloth, sequin cloth, work brilliantly, because out of focus they just look like little sparkly raindrops in a rainforest. So there we go. Use another one of our patented rain machines, spin the camera as fast as possible, and with a bit of luck, put a morpho on, and once it starts getting wet, it'll take off. So again, I mean, it's all about just kind of showing you the biology, but also dramatizing the images in such a way that they stick in your mind. Now then, that was kind of low-tech. This is definitely very high-tech. So it's all well and good moving the camera in a circle. Great, in fact. But what if you want to move it elsewhere? Not only elsewhere, like with the Wasmatron at really high speed, but also in a really controlled way. And that's where we needed this device, which is a sort of robot arm, basically, that was sort of designed by Nick. That's Nick Pitt, who runs Farm Studio. And he designed this thing, and then together with the robotics lab at the University of West of England, they built this thing, which is a computer programmable system for moving the camera in a whole range of different ways. And again, if the Wasmatron was scary, this thing at high speed is really, really scary. But you can move the camera in ways that you would never be able to move a camera any other way than this. It gives you really complex moves. It also gives you repeatable moves, because once it's programmed, it will make exactly the same move to the nearest millimeter in exactly the same way, which is actually sometimes quite useful for adding any effects or such like. So, but it also will move at ridiculously high speeds. So you can, as part of that rain sequence, we did some shots tracking down with raindrops to discover a stag beetle. And so you can program the move you want at normal speed and see what it looks like and get that exactly right. And then you can cue the patented thunderstorm, Phelan thunderstorm, and then fire the camera off, fire the robot arm off at high speed, and it moves like lightning when it's triggered. And it's a really powerful bit of kit, so you do not want to get in the way of it when it's doing that. It would demolish you quite effectively. But it works. I mean, all these things are a bit hit and miss, but the nice thing is you can keep doing the same move over and over again if you don't get quite what you want. But again, slowed down, you can see the movement. It's very nice, smooth movement, and it's a very a move you could not do any other way. So we were very, very pleased with those shots. I showed you the sort of translite system with the probe lenses, which is great. But insects, as I keep pointing out, can be very, very, very small. And even with the tiny ones, you kind of want to see a bit of the background. These are pavement ants, and we were doing a sequence of them living in New York City. So we wanted to see Manhattan behind. And we couldn't do it with translights. And plus, we wanted cars moving and stuff like that as well. So that had to resort to a different technique. Now, these studios, and we have used these for various things, are fantastic. They're relatively new. It's where they shoot things like the Star Wars movies and that sort of stuff. You have a massive LED screen, 30 meters long or whatever, curving around you, and you can build sets, be it spaceships or whatever, in front of it, and it will tie in, you know, exactly with the foreground, and you can then have the background, you know, running whatever it is. It might be computer effects or whatever if it's a Star Wars thing, but it's very convincing. All the more so because there's a massive screen above which you can put the same image on, which casts the same kind of light over the thing. Now, if you're filming, you know, guys in shiny stormtrooper helmets, it's quite an important thing. I guess it would be for doing shiny beetles too, but actually for most macro stuff, this is just too big, and the screen is too crude. I mean, we'd have to get so close to the screen that you'd see all the individual LEDs. So we had to basically adapt this for a smaller studio, which was relatively straightforward. Nothing's ever quite straightforward, but it's relatively straightforward with an 8K TV set. And with probe lenses, you can get a sense of, you're basically cheating how far away the background is, but your eye doesn't register that. It understands the image, so it thinks it's a perfectly normal sort of image, even though these ants are so tiny. So this was the resulting sequence.
Ants are perfectly at home in the heart of our biggest and busiest cities. In fact, there are far more ants here than people. Thirteen different kinds of ants thrive on the streets of downtown New York, where, like us, they crave junk food. Chemical analysis of these ants has shown they're eating the same food as the people here. Like us, they are hooked on burgers, hot dogs, and bagels. The most abundant are pavement ants. They're tiny, just a fraction of an inch long, but so efficient they do a great job in keeping the sidewalks clear of all the food we waste. Along just Broadway and West Street, these ants dispose of over 500,000 discarded potato chips every year.
Great. So in the end, you can see it can be quite effective, and you can use it for a whole variety of things. I won't run through this in detail. This was a dung beetle sequence on dung beetles that bury dung, which we wanted to do close to an elephant herd, it basically is sensible to do it in a studio like this rather than actually ask a cameraman to lie down on his belly in the middle of an elephant herd to do it. But it's quite effective. I mean, it does its job. The last thing I want to show you, and we'll have some time for questions, is I keep mentioning interesting behavior. And actually the one thing about trying to do stuff in studios is if you do it properly, you can get really interesting behavioral observations. So this was especially built, a bit of the studio, well, this bit was built at Portishead. That we're just building is a flight arena for bumblebees and for wasps. And it will connect eventually through holes and tubes to that hut on the right, which I will show you. We built an enclosure because bumblebee nests in particular can be very prone to attacks by wax moths, especially for some reason, I don't know why, but bumblebees that build their nests higher up tend to get more nailed by wax moths, which destroy the nest. And obviously our nests were going to be quite high up because they were going to be at a convenient filming height. So we could keep them enclosed in here and just feed them on, you know, prime, nice flowers and things. Or, well, once we had the wasps in there, we let them fly free because they could find their own food. And then the hut to the right there on the inside had a series of different boxes. This became known as the Hymenoptera hut because it had wasps and bumblebees in it. The big boxes are for wasps, and they're built to look like the inside of a garden shed. And eventually, as you'll see, we'll have a wasp nest hanging in it. The little boxes were for bumblebees, and they eventually would be dressed to look like a kind of earthen enclosure. And what it means is that you can keep them going. So this is Chris Timmins, who's our stalwart bug wrangler and bug finder, who found us queen common wasps just at starting the nest stage when they're solitary, and we got them into these containers and let the nests grow. And then every now and again you have to rip the outer carton of the nest off, which the wasps don't really like at all, actually. But we were kind enough to him to build the glass front. You can slide that out and then slide in one which has got like a sleeve in it, rubber sleeve, which a bit like a incubator or something, which allows him to manipulate the nest so we can film inside of it. And then when he's finished, we slide that out and put a nice clean piece back in to film through. And this is the bumblebee nest when it was fully established. And they lived very happily for a very long time, and you could literally just go into there and just sit and watch these things for half a day. It was a fascinating experience. And of course, it allows you to film, complex, detailed behavior over the life cycle of a bumblebee colony. So the last sequence I'll show you is just a few things that we got from that nest.
Another worker is about to join Team Bumblebee, with a little help from her sisters. She's a bit disheveled at first, but it doesn't take her long to dry off and fluff up. And then she's ready to play her part in keeping the colony well stocked. It's an awfully big world out there. And to be an effective team member, she has a lot to learn in a short space of time. She'll probably only live for a month or so.
Yeah, great. So that's a very whistle-stop tour, revealing all the inner secrets of how to make these films. I will have to kill you all now before you leave the room. I'm very, very sorry, but I hope you enjoyed the last moments of your life. There's the stalwart team from Planet Insect, lots of young, very keen people, and two old veterans at the back in Kevin and I, but anyway, we're still there, still drinking. And if I may be allowed a moment of indulgence, just to let you people know that this book is available in paperback now, which has got a lot of some of the stories I've been telling you are woven into it, although it's really a book about the insects themselves, and it's about why insects are such successful little creatures. It was published in hardback under a different title called Alien Worlds, so don't be fooled. I mean, it's great if you buy 2 copies because it's good for my royalties, but the Alien Worlds book and this book are the same book. It's just the Alien Worlds book, which I've got a copy of if people want to see, is a lot more colour photographs than this, but this is around at the moment. So thank you very much. Very happy to attempt to answer any questions that you might have.